Ah, okay. Yeah, okay. If you are ready to start. By Lia Longinotti. He's going to talk about gas outflowing in the Central Kiloparsec of AGN.
And it's complicated to lots of factors and really price. Eventually decided to look at outflow gas. And this is the talk about I see that I say all this and it's also I want them to retain some of these process. So I also want to say that what is the outline, but also say that each of this one required the time to the emergence by projects. So it's not really cited here. So I'll talk a little about the next vision having the Central Kiloparsec. Actually, Asian feedback goes by. Before the patient is treated by following by treated by observation of the cells and in the years again in the 90s and even because of the papers that basically found this unique correlation between the biomass and the gas. That basically that part was and they regulate their growth. So Australian results because of the universe and the weak without feedback. These are two models, and without agent feedback and observation feedback. So this agent feedback is the mechanism that we know exactly that is able to regulate there are several other processes related to AGN involved feedback, and this is asking how can we make Galaxies and without AGN, and they are listed here. And space, but in general, it's thought that feedback is dominant. And also, AGN feedback is really big of Galaxy models and simulators. Derived from bias models published here or again in general. But in there, and usually also includes this mechanism to produce the Galaxies that we observe. Otherwise, without feedback, Galaxy will be in blue, but with what stars, we go from the blue Galaxies to the red mass, that we know as the I distribution in colors of Galaxies. Outflows in this. Okay, so Clearly, when we have a supermassive black hole, which is infinity, which is the moment when galaxies is happening, the black hole raises a large amount of energy and mass of 3/4, basically. These forms are important. That's just very gas and very part. And this applies to the whole rate condition and the efficient AGN. So from our isonorms data. And we focus on the efficient speeds on up. This also works from an intuitive point of view. We measure wings are actually fragments to get outwards, come towards. So mass is in the AGN, the gas, and we can just use gas, and we can use the gas. The gas is key points. The gas is the next molecular gas forms. Because of two positive effectivity, and this is the feedback mechanism that is generating us. I think our we shut down of gas. I think it's fair to see about ways problems basically so positive okay, so system is the parser technically, so I forget this review and it looks the gap regions in different sample states, one parse, and then parse. And the difference is the color very well, but hot gas, the next rate means one has last color, we normally see most of lines. And you see that there are different cloudlets that shows possible outflows, and this is a very big also have stars, so we have information there, and gas, of course. So this is a very complicated business to understand how gas is flowing in the system. And I'll go through the different gas cases. But I want to say, when we study the outflows, when we talk about the outflows, this is what is the AGN? And we need gases flowing with a significant difference statement from rotating gas. And I think it's we made about why this of this. So I also want to say that this is a very complicated observation study because as you see there are gas with a wide range of energy density. So there are multiple observations of different or also physical depth. So I really have to figure it out. I see this and you can see one of the differences. Okay, so let's review some observational images of outflows and key measurements. And I'm sorry because I'm interested some, but this the HPVs in the hotspot space, which are located within parse space from the supermassive black holes. And it's important that we have in mind the two flavors of, there are two main flavors of HPVs, one of course the medium. Because basically HPVs are characterized by some outflow velocity, which is different over, and we say around the atlas or fast. Where outflows are very fast, up to 1 BGE. velocities. And in terms of condensity, well, like condensity to imaginary spectrum, and a wide range of frequencies. Yeah, there's components, but they don't get much mass energy of the AGN. In a typical mass operating here, some values carried out of 60 resolutions in the next reference. So this is the state of the art for expertise, and I'm going to show the advance that we have. Starting with this Zihuagn, and you see the 73 layers, the next construction remarks in two when you speak to anything that's the real line, this certainly here is tracing items consortium from many atoms, then we can identify what is the spectroscopy that is going to identify the and it's in wavelength. We have lines here, see the different series of several species and models, models, and have all the parameters. And the main advance, consists of a physics. Well, a couple of years ago, launched by us, and this is the practical energy that is pretty obvious. So, sorry, we that resolution has communicate, and you can see the improvements that we get here, where we get only noise, and instead of increasing, we get with the color, all the stuff of analyzed color. This is very important for experience because I want to solve the risk of it for basically this process. This components, this was modeled with what's called a QRP at appreciation scale. This is 600 very gravitational area. And basically, the power of stimulating very well these components, as this Planck model, in the appreciation is not a large spectral scale. And this is the macro is not related to it's but like more like an interpreted base parts this patterns. So these applications for the contributions with we'll see in a moment. So that was many analyzed once by what are communities, but analyzed the concept is very important. So the idea is not very this and in fact we also this what we call stratified HA protocol. This is one of them, that's for this was now. And it's important because it's stratified HA are this only one that should be factors of outcomes and we think more about this stuff. So I want to see we have two types of mechanisms for this. One involves the generation UV lights, and the other one is magnetically driven. Means there are much these lights, and it's really about genders, the solvents, these processes, magnetic processes only the end. I want to say here what mechanisms related early of the outward velocity of the with the ionization parameter, which is related to the source of the and this is why we want to measure all these components with precision so we can reconstruct the closure methods. Now, I want to mention a few events, the AGN. So, statement of what we know about UVs. Mainly was people of superman is time. These are others is about compared to uniform velocity see in presence. And they were very promising because maybe it's what yes, because our models were predicted outflows to the gas was clearly trained by the more powerful people before, but there's not so much association with the associations. We only have a few counterparts of the outflows because presence in the large. This results in experience provides a Irish universe. If you want to know that we expected and feedback that maximum where AGN is as maximum, so it's very important. Also, the traders division feedback between the target. It's a big challenge for trading. And there's this one paper on us that brought an expert who in this on almost 4. He actually found a very conceptual practice. Not agreement. It's like a nice one, very nice development, and we have this the volume of the device that I will put inside the lab one. So you can see that they are aligned with when we go in power index storage inside with the data usually the smallest are not enough to launch in space. What we can see after the case is to this part where we have cascade there are many choices here. Around there are many thoughts. It's taking more these outflows in this bands. So for bands for warming discuss very reliable ways to feel and balance in the width and the symmetries, some events, so size, oxidation lines, some of the old colors, which lines, I use very molecular gas, the gold gas with some point. We have molecular lines, CO weight, lines, and CVC. And there's a CVC, and it's also different properties. And also across very nice results, like we here at the Central Kiloparsec of AGN. I think about those related data where we can make those sites of hundreds of very different data. And we get to know the global properties through these large samples like this both SCSS outputs not to be other ones don't have really the X-ray because here this is in favor of the output because read the outputs of ability to which is So that's to illustrate the power of IFU spectroscopy. This is news. And you see that 1365 in the amount of survey, and you can see different forms of constantly green and H alpha in red. So that's the power of IFU spectroscopy. Traces the molecular gas. And atomic gas, this is that's the Zihuagn, where we can measure the of the world wings, which are out. Also, this in the atomic gas, so we can either 21 9 data. If I want to go to your this now we see this both cascades. And of course we have several wonderful results by the interferences. There is one by Santiago, where we see different dense gas lines. There's a new starting of view of the diagram where flowing gas. Because I don't say what measures. We want to measure basic stuff, mass, velocity, the radius, and this goes all into the derivatives of the outflows. And I want to say that there are many measurements, something of the outflows. This is the work on my space, so that's very practical on the paper by yes. We basically do it each time it's applicated that flow and its formula was and then this which is and we have lots of possibilities the games, right? Analysis and line proposition. And this is the biomedical. In the course of the phase, the gas is actually vertical factor between the luminosity measured still by luminosity compared to the H2 gas mass TI is parameter. There is vertical factor that is but range for the case for depending on that 5% entire beginning by a lot of all these factors. We can read more about this. Also, we want to look at the say, I think that means we can see that that's how we derive the velocity around the course, but protecting the best issue that I have by the common that's when we have an outflow of the camera on the plane of the sky. Let's see how the world comes on your lines. Typical molecular outflows it's done by from the speaker like that is for regular outflows. It's a compilation of results outflows and the values of the cycles back to 10 kiloparsec. Here. The outflow velocity in corporate outflows is around 500 per second. And in the sort of I would say that the values start with Unitarian because we don't have common values because we have made of us. We must rate. So now we're going to measure our outflow rate, the all those caveats, and our velocity of outflow. And as you see, the infinite power, that's the amount of energy that comes from this to Galaxy. And that goes with the squares of the also it's very important because of power of interface, which because we have a very great power. And rate plus a constant which is about the cost how it's doing. And what we do now, that we have studied the context related about the AGN, and we compare this with luminous which and we this is an efficiency factor for the kinetic factor of the output, which can be compared with the efficiency factor produced by the simulations. It's around it's within very high factor for about 5%. We see this process actually regulates stagnation and finally all of this we have this which does. So this explains things like here composers. Basically we were switched with these factors in the model predicts that the uniform with velocity this being velocity higher than 1,000 kilometers per second is not always that always process by talking into study and this introduces a short language for no so you see short even visualizing here with forward flow and sweat with ice and these another way my answer we want we think that this so there's this difference in front behind the short the sun produces multiple layers of gas with different ionization processes. Those which are one field much to observe and described by the speeds that I described before. And in this process, the shock outflow is provided to the galaxy and heats gas down. So this model also predicts the thickness of extended emissions around 1 So this actually that actually level of cost that very reduce. So how the energy is deposited in the stability depends on the type of shots gating and depending on who you go to shot. That's very thoughts, but it's needed in that is short is losing is pulling quickly then becoming strong and loses things momentum. Whereas if are light and they don't reach their energy, so the momentum of wind is loose and they will integrate into all the energy. And this is another one that is able to mostly get of the wind to allow outflows. What we do is put our measurements this graph. Okay, so with the outflow velocity and this is the momentum rate of the wind by the velocity. Velocity has scale out here and outflow winds here, and if the observed points in this time is in this freedom outcomes measure. What we observe reality is from this paper, and that's a combination of these plus you know see and you can see that are on the line of energy spectrum and so on. And so this is telling us this power that means are getting the energy and transfers to the galaxy and download. And this is explained by some by intermittent this is not continuous to galaxy. So basically, what this is telling us is that these outputs they not originated by the same generators. basically, I say it's targets with a critical station where the red previous space AGN feet. Then I want to talk about two recent case studies from one actually just stated about source most complete multiple examples I would say or 20 where in every single bar where it was from X-ray, radio, and regular gas, so we have concentrations, okay, and we have campus. And this is an analysis one. I wasn't going to show this part after we implies a lot of money. I think that that's example. So that's makes sense. And the next ones, the visitors to Galaxies, the mentioned in this connection, the red ones are now selected, which we selected and studied because we wanted to see the properties of the post Galaxies. We wanted to see they actually work in this analysis. One, I were able to how we were out of this information. And now sometimes they look most slow and enhanced information. So we see them, these are the similarity questions this money. And so we have this positive feedback from this analysis one next to and we're going to now, yeah, this so what about the actually it's led by our students, the volunteers, there are 40, so people in this project, and we have some semesters in the room. This is a project we can graduate experience next very complicated. For example, we use that's all the conclusions here. The questions is yellow here. They are actually populate basically the luminosity space with what and so we find basically see a very fractal beautiful in this luminosity range. Which is like the 8.1 of the volume ratio, contains 35 about result. That's the same correlation that could be called the charters, the videos, the records, we also combine those relations, but it requires this it's not as unlikely. We have a search with finds in time. Basically, which says usually why actually, but we don't find in UFO counterparts. And all the winds in the UV have much lower velocities, which are lower substances. And that is telling us that there is no agreement on the UFO, at least for these lines. It could also be related to ionization. You can do ionization, lower ionization, so related to ionization. Correlated with last saver, actually, where you also relate these parameters with identity properties have been studied, and the main result here is basically character energies, the outflows, and this is the locus coordinate, the outflows, radiation outflows, and some that are in this zone, which is what we already suspected from the previous college showed. And there's a data preparation by medications treatment with this America. It's very easy and really works. Sources of one experience versus the and from the local to show to study the regularities in speak of the properties, but the radio is very important because it's about local shocks, the universe cities. And so this paper actually finds systematic radio outflows systematically in all the 7 sources where we have a photographs, mass surveys, substantive examination. And so this is very important.
Yeah.
So that's the part of the talk I hear most. Because I was supposed to be clever and optimistic, and I was great. I also don't have anything, unfortunately. So, what are my conclusions now? So, about a lot of stuff. I think it's really like, yeah, that's how we find things. It's really good. We have one of those pages but the physical link between different outputs is the future is bright in terms of global studies of observation facilities. A lot of frequency discovery and the local, the markers, CSS, accuracy, everything, and the X-rays will tell us about output properties. We can do this computing studies with these surveys. As we version that interests or perspective on the advance of these things, they are kind of limited compared to the detail of other advanced associations. Conservation is not in terms of relate, because relate is not don't reach this target with counterparts. So that's the only part where the shock platform is actually working. It's not represented in simulations, and we don't know what the simulation is. So I think there's a gap between this observation and simulated ones. And if the observation is done, we want to do this not stuff. That's the way we see here. Yeah. Yeah,
another one. No. And
which is your indicating for transformation. What your thoughts, the transforming diseases. Yeah, which how we can we did yes yes. Yeah, and one of the programs where they are from zero to one, thank you.
And thank you for the about how the UFO technology is to for houses, it was for my case, it also be in terms of much
Okay, and most where the audience realized us are very audiences where there's no. So the attack was the TP virus, or virus with TP, which yeah, and also I don't have evidence about that. So, for example, Lia will show this will go up. That's my point of the mechanism we get you. The unlocks questions for young adults and others. I think it's very important.
Yes, yeah, that's one. So the question I have, so how are actually, so you presented all these different output types. So the question can all that you say is you didn't use it all in your community. But for example, for studying your source of something that you actually have one source, all of these outputs. Can you derive actually how these studies could be incorporated outputs, or are they one output maybe in the next?
People don't, were very enthusiastic about this college when I came out with me. And then when I was started with last year, started for year, no one was doing this. And so my study, we had a very good relation with the oral appeals. And so you're asking how each different base is connected with each other. But that's exactly what simulations from the X-ray point of view, simulations tell us. Models tell us. Beautiful model of the shock once the beautiful impact they guys say we don't have any prediction what's happening. It's so for example. We only know that we have is women have television. X-rays we can see each other, which we have so this television is very created and things. Station that but we can
Yes, there is a new quite like okay. So the next goal is my location. So we go, yeah, I can start from liquid from AGN with nearby applications. Please. Okay, so I want to give you a review of last year's research groups efforts. And you can see the names up here. And in particular, I want to point out all these people live streaming and talking here. So if you haven't guessed it by now, this is the setup. So if we take a look at ancient history, Hubble's early nearby pretty quickly see that now but the nearline region is very long. And it would have the ability to actually get spatially resolve spectra with sets. So here's a set going down the region into the we got to look like this, and it's kind of in the time because not only these individual amounts of emission, tens of parsecs and times have their own sort of repeated velocities and widths, but in neuron which just shows on pattern. The pattern that we see is you can see here. Oops. Increasing velocity starting around the zero of the galaxy to some current rate and then decreasing velocity back towards the center. We see that for about, from maybe engaging that we observe, I thought it shows very radial velocity signature. So what we is that narrow clouds are outflowing velocities. In this case, about 68, that many of them show the spur radius on the order of hundreds of parsecs away from the center. It's like, oh, individual clouds often are having large velocity that's up to about 1,000 kilometers per second. So you can interpret that as turbulence or gradients and flow. It's not quite clear what some of these waves are due to. So the way that we analyze our spectrum at each position on a slit or within a few observations is we use the basic evidence analysis tool or B to develop a test picture. And what we do is we determine minimum gases that you need to fit the narrow lines. And of course, sometimes we deal with the broad components as well. So we put that first, and then we fit multiple components. We find 2 or 3 components near the nucleus, and we supplement our observation or IoT observation with a ground-based observation that's the observatory, long split observation. The track can into the galaxy that allows us to more easily separate rotation outflows, which are the 2 sort of things that we see. So here was some earlier results that we had where we just pay attention primarily to the bright clouds. And that's an okay job to see some acute velocity. And it's needed this characteristic increase in velocity followed by a slower decrease towards systemic, just the rotating component along the minor axis of the galaxies of the rotating component. We are able to sort of deconvolve the outflows from rotation in this finance test. And from the models that we fit to the data, then we're able to obtain the true space velocity and the true distances of each individual cloud from the sequence. So we also first did this relying 2 observations, both with AO and voice. And if you just read you get multiple things. We also get this color components to the representation. The middle view here is the norm molecular time speed, and you can start to see separate things here. You can start to see some outflow, and then you get to the ionized step, you see very well relative gas. And so this picture that the spiral vessel coming into the nucleus started to push the gas all in the reservoir gas. And it's warm and then it gets ionized. So it's transition from a cold to warm molecular and then to ionized gas. And that's what we find is basically AGN radiation ionizes and accelerates the cold gas from these conducting molecular reservoirs. So what we've done next is sort of the mitigated trajectory and you can Galaxies to this like figure this out. But basically the end and the calculation of the modifications. And the modifications are is that on the radiated acceleration side, we have a force multiplier, which essentially is how much more effective is radiated driving compared to constant scatter. We're combining as gas with the free and acceleration as not outline more effective than just the constant scattering. So that's the radiated part. And then on the gravitational deceleration part, we not only do massive black hole, of course, we're shooting out into the low galaxy. So we do the enclosed mass of all the star and gas that are interior range. And so you get these trajectories which all have a turnover point. So the turnover point here, the turnover radius, then is a characteristic of each situation, regardless of where you launch the cloud. So you get a particular cloud that's like and trace back its longitude to focus here except for long. So again, we're using constant work multiplier and the enclosed math to develop these trajectories, partly on these ones. So the idea then is we can now use these turnover rate and calculate, taking all this along for but we use this calculation to get for models turnover data. And then we can go to our observed kinematic model turnover rate. So let's just the third columns down here, and then up here we have the model. So what we find is that there's a pretty good match between the two. If you allow the force multiplier to vary between 500 and 3,000, which we get in cloudy models, on the ionized space of the cloud, it's more like 3,000. If deeper to the cloud, you get 900, but you get a much lower force multiplier. So we're seeing a range here, which is sort of telling the extent of these points. Those are the error bars. And so, bottom line is the correlation between radiated acceleration and gravitational deceleration. You just those two forces, then those are the dominant forces in the neuron. Okay. We also determine spatially resolved mass outflow rates. Sorry, we also thank you, we also resolve mass outflow rates. So what we can do is use that to get the true phase velocity distances. And then we use photonization models to actually determine the density along the slit in this phase. And then we actually use annual mass along the split to the rest of the neuron region. All right, so what did we get? I actually showed one of the plots from Walson's paper that where you don't see I'm showing the other half you see the return number in the mass outflow rate. And this is primarily the velocity you see in the data. So we also want to point out that the densities that you get from these sort of determinations, have a huge range, typically to the 50 or 6, very close to the nucleus of 1 parsec, whereas 2 parsecs. Out to about 10 to 2 per kilometer. So we're calculating mass rate, and we then what we do is do this as a function of velocity. So we've accumulated enough points now to sort of plot the mass outflow rate as a function of luminosity. There's minus. We can also do this with kinetic power as well. Once again, you see a nice point here. So we're finding mass outflow rates anywhere from 10 to 30 solar masses, depending on the luminosity per year. And there's some evidence here that as you get to somewhat lower luminosities, starting to translate over into low luminosity AGN out here, that the outflow can actually not occur in these. So the conclusions are that mass outflows of ionized gas are ubiquitous in narrow regions of moderate luminosity AGN. So we find radiated acceleration of nuclear is the dominant forces of ionized gas in the alkaline region. And the winds come from ionization of cold gas reservoirs and subsequent radiated acceleration. You may have been from 100,000 parts of the luminosity of those galaxies. So what's the future look like? Well, this is where I sort of lead into my colleagues' talk later today. We are really primarily just pure radiated feedback. So of those 3 radiated winds and jets, this is just radiated feedback that we're talking about. And we can see its effects. And kind of guess it's sort of how important it is. You can actually see the gas being evacuated from the regions. So what you can do with that, and Felix going to talk about this, is that some of the mass gas reservoir along observations, you can calculate the vacuum. Once the oil that we're talking about, determine gas increasing again. Well, going on sort of the solar. We didn't talk more about what's the impact of stuff. So you see that in this talk. And then Mark's going to talk about a specific case of AGN 87.319 and a special environment in Zihuagn. And then sort of finally, doing things follow luminosity. That's what I'm working on now with several students. So we just show a movie. So show it. So this is not going to be, but I really like it. And because I'm using those, and I was the first time I saw them on the movie, I didn't like it. I thought it was important for here, but I walked in and sort of started learning to like it. So I had to see these several times. Recommend that they didn't have a lot to have so much evidence private. It's like that. It's like a video shows me something. Yes. Just a question for Mike also was is mining research. You know about especially these nearby galaxies. You don't know what is the loss of the and this is the next step. The good baseline. Because the face value of the I need, let's say that the general aggregation in general is sort of imbalance of the local go so far as from the whole beeline that's their deviation. It's not it's not saying not how it results. Seeking some baseline for the conventional rate. So the result of primarily studies. And so when you expect the false spectrum at on Saturn, you can see the dominant force is actually the deceleration. But when there's areas with a bunch of gases around, then you start to see the rotation, but it's not dominant. So we actually are able to see both components most of the time, and you see rotation in the outer sort of splits into rotation plus outflows. We're trying to come but basically even do care about so that's I think bridging that gap from the nucleus to the process. That's right. And if you care about the global effects, these are probably not the ones you look at because the effects are typically within the kiloparsec. And so but we are moving gas from the regions. And so really one of the times at least or we would decide AGN is the power. Okay, let's take another one. And now it's about the logic of the mass rate to the distance. But this way, these behaviors of this. Yeah. What's the explanation here? Yes. So what's happening here is that typically when we calculate gas rates, we do expect offset. We also calculate the nuclear outflow rates of what all the mass is concentrated within the inner resolution element. And that was just a careful experiment we did in that case. And so what you find when you compare it is that for any one of these mass outflow rate curves, you get a much lower total mass of total mass of this. So that means you carry your mass from these reservoirs of gas as you go further around. And then this sort of reflects the downturn that you see.
Thank you. Okay, the second, the three now. The second, Matteo Ceci, il tocca il strike finale. Yeah, non compite lei. Please.
So, Matteo Ceci, questi che ci spiegano dell'University of Florence today we're going to present you our clinical project about the study of general flows in the nearby universe thanks to the Galaxies. Yes, so after the introduction, we'll present the program itself and the main modeling tools used to obtain our results. And at the end, I will focus on the Galaxies and you see why. So, first of all, let's know the evolution of the galaxy is connected to the Big Bang. So, one of the main aspects is on the galaxies. As I told when we talk about the objects, the outflows, we are talking about this stages. So, if you want to find that and feedback, start to obtain the side and accurate and start of using different stages. This will give you a name in the universe, where you can exploit the files looking at data and the state also the other elements. For example, until we are resolved by Volato, they find a overlap between a molecular outflow, set by lambda, and the derivative outflow, called by the user by lots of variables. But nowadays, the main problem of computer and obtaining the masses and the energetics is the fact that they get uncertainties of pure time. With this in mind, we decided to start our miracle. What miracle is for the different peoples, and short. And the main goal of the project is to study morphology and the energetics of disease and outflows. With the study of molecular and aspects easy to and also try to face the resources of the application with example moving regions patterns. For example, the local gem with analyze and molecular paths. Let's talk now about one of the first questions: why we need the integration? Why we need? First of all, in order to fix the sort of organization, for example, as I said, the gem team, we need a species like a file for the oxygen flow that have a very high ionization potential. And what is like for in the range. Why, for example, in the optical transition, we are just for the involved that can be also by this scanning. Then the next, as you know, in the optimal, we use the system the side S2 line. The main problem is that each subgroup almost 10 before if we need high value of density in the middle, we have a lot of data, for example, we find then to reach up the distance. Last but not least, efficient. These are very structured to the significant region of any sequence slide. So stellar disk overlap by one outflows. With the uscita del container and behind the relapse, the stellar disk, the one. As you can see, in the optimal is used in the whole field. You can then trust the uscita del container. The other one is then obviously by the dust of disk. If you move quite near it, this is the new file of protein macros, we can do that both things. And again, this is not because we want the result of the axis. So let's talk about the modeling tools used. This is a Zihuagn, a photorealization modeling code provided developed by Santa Marconi in Florence. The code tries to reproduce the second transient the combination of single cloud images. Very quickly, the idea is the same behind the XF code. You want to reduce stellar energy with the stellar X. This is the same part of the code process. The other one is monotherapy. The Zihuagn model developed by a student in Florence was one machine. In this case, the code after the assuming the geometrical distribution of the cloud that reduces the best answer to external mass. Here is an example of the significant external mass below the model of Moga and Galaxies. Let's talk now finally about the main character of the presentation, that is the Galaxies, that is Spatially-Resolved. The reason to use in the background continuum, and I'm going to see it, but trust me, these two are the tasks by partners here. They are faced also by so in the side of the use. In blue, we have the entry that is facing the different outflows. If you move in the other to the side, you change the background of the continuum to the occidentally. E lo stesso riguarda il concept just dell'uscita compiti, no? In my finally, this is the so-called 3 and 13 minus. In this case, we are getting both the outflow, the shape, and the Zihuagn cluster coding. These are constantly updated in our theory, as you can see, we have a couple of lines, almost 30 mission lines, facing the analyze data, the computational HT transition in silent and blue, and on the continuum, you see a lot of the maps. In this work, just as I was speaking about, and then we didn't start the age, but we and now to talk about the problem of the data, the fact that there are these discontinuities, as you can see from the step again, between subchannels. This is a well-known problem, probably due to the data line. The reason is that we have to design bodies to the oldest engine code. At the end, give us a total data group in which spatial experts will get spectra ranging from 5 volts to 28 minus. And if you want to pay the totality, it is available. Then, for the moment maps, we found that the species of organized carbon and follow the outflow distribution, as you can see from the last map, while and is strange factor in the velocity spectrum of that they might be Then talking about the lower ionization potential species, they follow the start basically with the sequence diagram. computing, and is the development patterns. Similar behavior for the whole molecular gas based by H2, and also the whole molecular gas based by CO2 without. Then we applied OGAN. As we remember, in our film, there is a way out between the celebrities and the outflows. So we decided to use two components in the filter, using both AGN models and Spatially-Resolved. We almost visualize and use our solution. How is that? Told us first of all the AGN component, so the outflow as 6.4 as is nested filter as stellar piece, which is 3.3, as expected by manager results. Then we are going to use what this is our model of the outflow, where the model represents the velocity, the other side, and the size of the physics, the faster. For both the unified and also the mock-up, gave us the outflow of Let's talk now about the result of source. The argument mass aggregation. Quindi the classical method involved to compute the total alpha mass with a unit of the for this case it considered unified. We need to have some samples. This is a very simple. That is the number of mistakes minimum values in this one of miracles. And we only get no in this number. So there is a long very obviously the strongest and longest attack on this relation, but with answer. We can have a classical formula where the dependency of S. With OGAN, this is the most consistent because because currently the data mass from the calculation factor, the feature, the velocity of the line, and the support is actually just the generic component. With this, we obtain these simple formulas, taking also into account by the extinction. This result, as you can see, we are the method very different, but we can find we have a 40 difference between standard and shoulder, and of for the oxygen. And also you see the estimation of M5 and oxygen B with the for the outcomes. The people are synchronous and co-creating. First of all, we are assuming that, for example, the oxygen is in the oxygen for the new in the uniform. Then, in the classical formula, we use the density used by just simple double, down the 5. And then the finish is completed by customer. With OGAN, we have a more consistent way to list the formula with important for this aspect. The density, the state, and the extinction. This example, we don't have found that makes sense. The total minimum is the following for us. Here I show you if you also have an object, particularly to solve the fact that we have two of the difference for this measure of outflow must state in time, depending on the use. So, the summary I presented the output miracle and the result of the MC Galaxy, but important the digital media is a consistent way to the outflows. The future is that to study the sample maybe some the different statistics from this program, and also to try to move the past features and the agency. Before thank you, I want to like talk about outflow design. Is a imagining the also the outside of
Question?
Maybe you mentioned that distance. Do you have an estimate of this like now how rate how much
so wait. No, we found this very part I mean in addition to the other also so but no, we found this estimation of the dollar of mass rate, but you take it because basically this again part of the main problem of these situations. As you know, the negative W are different. And you can see channel one has a particular position, for example, the nucleus. So we just include the natural state in a sequence region, so in spot update, taking into account all the sides of the atom, just the so
Okay. Yeah.
So, yes, question, but I guess I really appreciate if there's a map that you show like 3D very more volatile and self-performed, but again, this is really different and see more on this class. We're getting that I was thinking about starting. I think I've never seen it. It's not that it's that getting here that's pretty easy to yes, you're not revealing an event of like extras. And so if there was any kind of findings that suggest would love to see it, and very much would love to see it for proposals to say that's meetings.
Okay.
And I see that so is that how do we connect from a station here?
we notes. Assign the extension law and the considerate with all the initial lines, so the optical ones and the different ones with the same. So at the end, sorry. Okay.
The last one
We have just to show the output of this of the for example, the line, both the model estimation, the velocity, and the result of the AGN component is the second component, and also the AGN one.
So it's not based on the model. We have
yeah. So yeah. I mean, the recognition lines, the cluster, I don't know, for 3 lines here, we are taking 100 sensation on screen. I think we'll see. Yes, okay, yes.
So the last one.
It's over and up.
No, not yet. It is
No more questions. As I said, Matteo Ceci. The standard lineups work. Yeah, there is a lot. Yeah. Yeah.
Yes.
It's more. Yeah.
It's a good function. It's like SD, and we work, we model the SD for different types of PDN in order to see their particular characteristics. So, what we see was to convert to those. We firstly want to know what we say about the first so here on the east side. So, we convert those together and after it has a model of engineering that's called CP. And once the models were trained, we noticed that the was introduced to ours. So once we trained all the models, what we did was to compare for different speaking was to see what we could see in general test. So we had stable ones, stable two, 5 years, 7 years ago. We noticed a lot of stuff. Like, for example, that Q cells are unique must have synthesis type of C compared to those with ones with one atoms, potentially that or like these two bond shaping those. And for example, things like if I can see produced, not only have an ion age contribution, but also they tend to have a less than colder AGN contribution. So we have a lot of things that we can notice not only from the shape, but also from the environment that we've taken. So we want to know a little bit more of his work. But you also see we have the posters of everyone here. Then which we have everyone will be masters. I have Zihuagn, I'm currently a postdoc, Central Kiloparsec in New York. And my scientific mission is to understand immediate boundary roots in the galactic context. This is the opportunity. This is one galaxy context model. We're talking about this actually the scale of the goal. My full choice here is to go with this connection. I am looking at the company solar solution, which is an app with all of the massive strong it's just some is the universe of IBH. The model also produces the image of the million of those with the environment, creating the supernova explosions, it's still a gas. So one of the main things of this one is that we must explore essentially don't want to work unless we let anything use as okay, we look at that provides energy like mass independent potential law of the galaxy will pass to the mind to keep it. But maybe a little bit counterintuitive is that in this belief, because everything is more low mass, even individuals and slogans and unlike gas from useless can significantly impact acoustic flow is now to some aspect of the cycle against. Finally, using cycle technique, we also show that doing as how the logic in bringing or in the possible negative lessons from class with the dynamic mass specific objects, so you have dynamic friction, and also providing SaaS that can be started like and pushing by pushing so if you're interested in any of these things, and I'm also interested very much in the potential connected scenarios, but it's very to chat about.
Hi everyone, I'm Matteo Ceci. I'm a PhD student at Instituto Zihuagn in Milan. we some symptoms processing we found physical direction related to the circulation rate, but where it is, well, there are no engineers yet, but we are outside, and my recommendation is paper basically about Galaxies. Thank you.
And today, all we looking for the details project. Those details will be for the exhibition. Right now, I'm going to say these questions, inspired development, and the answer. The question was talking about the exhibition. Your answer is yes, my answer is maybe. If you want to know on the show, on the show field, if you observe the speaking and use virtual, my European. Okay. European today is people is setting policy following the journey of hashtag who does the existing and
This is we use 5 ways for our project, and that play everything. We focus on theta and Excel to calculate the masses of flowers, and we use a code named Javelin to calculate the delays. And Messi multi-epoch analysis from the spectrum of this sample. And the poster is open. Thank you.
Good morning, everyone. My name is Lucas Cortez. Right now, I'm postdoc at Finland, working with brain blood questions. But today, I'm going to show you a specific perspective. Galaxy called Galaxies 100. And it's special because it is part of an isolated sample. But from all this sample, this part has a signature. So actual spectrum, taking it in 2006, and after subscribing to Galaxy, we noticed that we have typical meaning. However, in collaboration with Paula Mascani, we took a second spectrum of this element, and we noticed that something changed in this galaxy. We took a we offered we confirmed that after starting this galaxy, the second component remains this galaxy, but the big feature is so what happened with this? So this work is about to explore the big picture. We started with this model. We are also this analysis. Even we made a study of the large scale environment. However, for this case, this is one time again. that was the upload method that it is that will be used. If you want to know more about it, read next week. Thank you.
What to say is the end of the session?
No.
I have an announcement. First, I would like to apologize because we didn't organize the yesterday. We were exhausted, but now we are good, more or less. So we are. La Agustina is for those who get it online, it's by those there is. But this time we want to make a reservation so we can try to see all together and be more organized. So for that reason, I have a paper here. Those that are willing to come 30 days for this time, please put your name next to the current reservation really large.
What time?
8 p.m. Go, please.
Okay.